Hi, good day. This topic is about the graph theory, real-life application of Chinese Postman problem. I am Shalami Mayor.
And I am Lance M. Aurelio. We are from BC1A.
Suppose that Lance Maurelio is a delivery man instead of a postman. He had lunch at his house and was going to deliver the remaining parcels throughout the city. He must first check the parcels, then ride with his motorcycle through each of the streets in order to deliver the parcels. Finally, returning to his house. He's tired and wants to complete the route quickly so he can get rest for the day. Here is the map of the selected part of the city of Tacloban and the total length of each road in meters shown. How can he minimize the distance traveled and deliver the parcels as efficiently as possible? Chinese mathematician Quan Meigo proposed a problem in 1960 dubbed the Chinese Postman problem in his honor. This problem can be solved with the graph theory. So let's begin and learn more how to apply Chinese Postman problem in real life.
Hi, I am Lance and I am a delivery man. In the Chinese Postman problem, we want to find the most efficient path to help to finish my deliveries quickly. This problem can be represented with the graph that includes edges and vertices. The graph each intersection would be a vertex and each street would be an edge. The ideal scenario for me is to travel each street exactly once before returning to my house. If we can traverse every edge exactly once and finish at the starting vertex, we would have what's known as Eulerian graph.
But how we figure out if a graph is Eulerian without just guessing and checking?
For this, we need to look at the degree of each vertex, which is the number of edges attached to a specific vertex. If the graph has vertices that are all even degree, the graph is Eulerian.
That works, but why?
Well, if you have vertex of degree 2, then you have edges connecting to that vertex. One edge to go in and one edge to go out. Therefore, you have an even number edges connecting to an intersection. You never have to travel an edge twice to travel through that intersection. However, if you have a vertex of odd degree, then you have a way to reach the intersection but no way to leave it without traveling along one of the connected street twice. If the graph has exactly two vertices of odd degree, the graph is semi-Eulerian. If the graph is like this, then it is just regular graph, not Eulerian graph.
Oh, I see. I have noticed that the city could be represented by a semi-Eulerian graph. That would be great, right? Wow! And now that we know a bit about graph theory, we can start to build your path.
Yes, and we have this following step for the Chinese Postman problem algorithm.
Wow! So the step 1 are listing and counting all vertices with odd degrees. So we have here the B, F, G, and H. So we have 4 vertices with odd degrees in total.
And then, the second step is to list all possible paired vertices with odd degrees. We are going to use the P over 2 to identify the number of pairs in each set. 4 over 2 is equals to 2 pairs. And then we are using the arithmetic sequence like this. Depending on how many pairs we calculated, it is to identify how many sets of pairing. Since we have 2 pairs, we are using this 3 set of pairs.
Since we have the 3 sets of pairs, so we're going to find the shortest path between each pair of vertices and add their shortest paths.
Right, and now, we identified that the least shortest path are the vertices B, G, and F, H. So in step 4, we will duplicate the edges B, G, and F, H.
Yes, and lastly, in step 5, since you're going to go in every street, we can find the weight of all the edges including the duplicate edges. We're starting at D to E, C, A, B, G, H, I, E, F, H, F, G, B, C, and ended to D. And it has the total weight of 3,571 meters.
That is awesome! It really helps a lot.
Yes, graph theory is incredibly amazing, useful with its applications, and surprisingly fun even with something as delivering parcels.